Okay. Um, Welcome everyone to this presentation. My name is Pablo and Pablo Neira, and I'm going to talk about all the updates that have happened in Netfilter since the last Netdev conference. Um, so I'm going to basically focus on the NFTables releases that happened in the last year, and I'm going to make a brief summary of the Netfilter workshop that took place in Dresden, in Germany, a few months ago. So we have had 4 releases in user space for NFTables since the last Netdev conference in 2022. We've got 1.6, 7, 8, and 9. Basically, the pace of releases for user space is around 3-4 months, as you can see. And I'm going to make a great summary of those updates that happen in those releases. NFTables 1.0.6, we got fixes and improvements for the dash optimize option that is basically providing hints to users that are migrating from IP tables. This rule set above is quite IP publish. If you look at it, it's basically a good number of rules with the same selectors. And it's basically the input interface name, the IP source address, and the IP destination address, and just the verdict. In these selectors, some of the values are the same, some others are different, and as you can see, there are also ranges and also prefixes. So basically, this is suggesting you to coalesce all these rule sets in one single rule using concatenations, basically taking the 3 selectors and putting all the values in a set. The optimize option is using implicit sets. When the number of rules that are coalesced is considerably large, it's convenient probably to make another transformation and move this to an explicit set. This is not currently supported by the optimize option, but it's something that can be explored, can be enhanced later on. So currently, all the optimizations are based on the implicit sets. The set that is picked from in the kernel is based on the features that are on the values that are used in the selectors. In this case, this is completely transparent to the user. We have different kind of backends. We have hash-based backends for exact matchings. We have an RB3 for ranges, and we have another set backend whose name is Pipapo that can basically match on very much everything. It's logarithmic lookup time, as it happens with an RB3. And it's so flexible that allows you to combine all these selectors with different kinds of values as prefixes and ranges, or even exact matches. So in this case, the kernel is picking Pipapo behind the scenes, so the user is not responsible for this. So more optimizations went into the optimize option. This is another example. In this case, the user seems to be having some level of understanding of NFTables, and is starting to use sets in a very timid way. As you can see here, you have 5 selectors. Is meta input interface name, IP source address, we have destination address, and source and destination UDP port, and then the verdict. In a rule set with a good number of repetitive rules like this, the optimize option is going to suggest you to coalesce all these 5 selectors into one concatenation, and then place all these values into the implicit set. So basically, this enhancement is targeted at people that are starting to use implicit set. So this is not anymore a straightforward IP tables rule set that was translated to NF tables, but the user already made some transformation, and before this update, it was not possible to equalize these rules. So now the optimized option is also starting to deal with rule sets that are not so much looking like IP tables, but also starting to use NF tables features. What's next? We have, it was already possible to match on destination port, both UDP and TCP. So this is not something new in 1.06, but I decided to introduce this example in this slide because it's actually related to the next item, which is this uncommon match. So NF tables is also capable of matching on strange transport protocols like this 91, and then match using the raw expression to match on at any offset. The offset here is expressed as in bits, so this is offset 400, and then the size is also expressed in length, and this is basically matching, making sure that those 2 bytes are 0 and then a protected packet. I guess that this user is probably doing some kind of port knocking implementation using NF tables, because otherwise I don't find a good use case for this. But someone reported that it was broken, and now this is fixed. There are plans for releasing a new stable release of 1.06. This is the work going on this. We collected already 41 fixes that have been backported from the 1.07 and 1.08 and 1.09 releases. So basically, and there are proposals for more backports to be included that can be very easily integrated into a stable 1.06 that can be collected via cherry pick with Git, so quite straightforward, and then basically run the test infrastructure we have and make sure that we don't break anything. But so we are planning to make a stable release for 1.06 and maintain this at the best of our capabilities as we move on. Next release was 1.07. This release contains a feature that I discussed in the previous Netdev conference. It's the inner header match. 1.0.7 is the first release that contains all the features available in kernel 6.2. So this feature requires an extension, a new NF tables expression in Linux kernel 6.2. So up to 1.06 contains all features up to kernel 6.1, and then 1.07 in 6.2, in Linux kernel 6.2. So what is this feature? It's, as I explained in the previous Netdev conference, that is now, and this feature is now available in tables in public releases. It's basically allowing you to match on inner headers that are encapsulated in some kind of tunneling protocol, such as VXLAN, GNV, GRE top. Currently, it is forcing you to match on the destination, on the UDP destination port, to restrict, or basically to restrict that if the tunnel protocol runs over UDP, then just make sure that we match on UDP transport packets. And then this is allowing you to match on these inner headers. For example, let's match a destination Ethernet address, or just a layer 4 protocol that is announced in the IPv4 header, or just the IP source address that is encapsulated in this VXLAN tunnel, or also layer 4. So basically, this new extension is allowing you to match on anything that is conveyed by the tunnel packet. And the good thing about this is that you don't need to, for a round trip, to decapsulate the packet using one of these VXLAN, GNV, GRE top devices, following the classic model in Linux that where you can filter first on the tunnel packet and then on the decapsulated packet. And this allows you to deploy stateless filtering, and you can also combine with all the features. So this is not a specific, it's not that you can do simple matching like this, but you can combine it with concatenations, set maps, and all the features that are available in Netables. And if one of those needs the feature combined to this inner match is not working, that it is a bug and needs to be fixed. But all the facilities available can be combined. And Netables 107 comes with an enhancement for the auto merge flag. This is basically allowing you to delete an element or a sub range existing in the range. For example, let's say you have a set with just TCP destination ports, just two ranges, 24 to 30, 40 to 50, and then you just want to delete port 25. So this is because the auto merge flag is toggled. This delete is going to request the kernel to remove the 24 to 30 interval and add one single element, which is 24, then another range, which is 26, 30, and then the existing range is left untouched. So it's basically dealing with incremental updates by removing an existing interval and then splitting that interval in two. This is all transparent to the user. It is user space that is dealing with this. This also can be also used with an IPv4 address, any kind of data type with that is available. This is only supported with singleton selectors. That is only TCP port, so TCP port or IPv4 port. No concatenations are supported with this feature at this stage, and actually it would be good to explore if that makes sense. There is more improvements instead of scalability in NATs. In IP tables, it's quite common that you might end up with lots of rules in the NAT table for every specific NAT mangling that you want to perform, the stateful NAT mangling. In this case, the destination NAT depends on the following concatenation, the concatenation of two selectors that are IP destination address and TCP destination port. And so based on the values that can be also ranges, it's going to pick a destination IP address and the ports that are going to be used to restrict this to be used for the DNAT. So the IP the persistent flag that is shown in that example also is something that is signaled to the NAT core that also exists in IP tables, that basically tells the core to hash IPv4 and IPv4 source and destination to make sure that flows target at the same, coming from the same origin and targeting to the same backend, always get to the same backend. So just to make sure that classic HTTP traffic doesn't break by sending some flows to the wrong backend. So, and then another feature that is available in Netables 107, which actually has been there in the kernel for a while, but I took a bit of time. I lacked to finish the user space part. It's the last used expression. This allows you to specify that you want to store the last time that a packet has matched an element, or can be also used for rules, but in Netables what matters are sets and maps, right? So it's better to use this feature in sets. So in this set definition, you see there, it's combining, it's a concatenation of two selectors, is IPv4 destination address and TCP destination port. There is a limit that has been set on that set because it's dynamic. There is a timeout of 1 hour. After that time, the entry expires if see no matching elements, packets matching elements in that set. And then there is this last used expression that is going to tell to store, to attach to the set the time that this set has seen a matching, this element has seen a matching. And then you have to use this set from the rule set. In the example there, it's basically output traffic and just storing all IPv4 destination address and TCP destination port. And it looks like this. Well, listing the set, what you see is basically all the destination IPv4 addresses and port, and the last time when this element has seen a matching. The expires, if you see the expire is kind of reversed in this case because only one packet has matched in this example. But basically, if you use update, the expires is going to be refreshed to 1 minute, and then last use is going to be exactly 0. So this is because update is used. If add is used to update the set, in that case it will be the last use will not be updated, and expires would be the time when the entry was created, right? So, well, that's basically the last use expression. Scalable quota. It's also available since Nftables 107. This is the Netdev table X contains a set with basically destination IP address, and a quota is set over 10,000 megabytes, and then it is used from the rule set to match on the elements available in that set. This set is not dynamic, so it's basically control plane that is adding elements. In this case, I add an element for IP address 8888, and then the effect you see is here. So a new entry that was added from control plane got a quota, and every time that there is a packet, in this case I just ping to 8888, it starts consuming the quota that has been specified. You can override the default quota. That's possible. You only have to specify explicitly what quota you want to add to that element. So if you didn't specify quota, the default quota that is set to be used in the set is taken. Otherwise, the specific one that the user specifies. A new destroy command that has been asked for a bit of time. It's basically allowing you to delete all kind of elements, all kind of objects available in Nftables, either tables, chains, sets, maps, counters, quotas, and it never fails if the object does not exist. And because delete command fails if it does not exist, and also because of the transaction semantics in Nftables, that is, if one command fails, then the entire transaction is undone. Then this was a problem for people that wanted to make sure no previous object existed. So there is now a command to make sure that an object does not exist before I'm going to create it. In Nftables 108, we got an announcement that requires no kernel update, which is something that has been requested for a bit of time already. That has been basically a reason for some users to keep expressing rule sets using rules, which was the lack to attach a counter stateful full expression to an implicit element. So this was already possible with explicit sets, but it was not with implicit sets. It's, as I said, it's just a user space update. No kernel update is required to do this. And this example, the first example, shows how to match on the meta mark that is available on the escape buff, and just match. If meta mark is 10, then count, or if it's 11, then also count packets matching that element. Also, a quite common idiom that is used at the start of the rule sets is this one when you use connection tracking, which is which, as I said, is quite common. In this case, this is this a city state match to match on the state, and you can use a vertex map, and again use this counter expression to match on the corresponding city state. We have establish, and then we count if there is a matching packet on the established state. In the established state, then we accept it, and then same with related, and with invalid, count and drop. So in this case, you can express the classic two rules with established, related, accept, and count, and then another rule, or to say invalid, count, and then drop, right? In empty tables, the counters are always on by default. In this case, in empty tables, counters are available only available on demand, and I can see there are some questions. Does the optimize option increases performance, or is it just for convenience? It does. It does. Anything that help utilize sets and maps more improves scalability of your firewalling. The problem with the rule sets are basically linear rule set inspection, and the sets and maps allows you to basically match in case of if it's an exact match in O1, and in case that you are using ranges or prefixes or something that is not that is wider, it's a logarithmic matching lookup time. So it's always convenient to utilize sets and maps more and more. So one of the things when adopting NS tables is that you have to change your mindset, and you have to start thinking about maintaining a rule set by rules, but instead thinking how you can express things with sets and maps to basically reduce the number of rules that need to be inspected to find a matching, and then let the packet go or drop it as soon as possible. So yes, the optimize option is good to be run in existing rule sets. If you have some of them that were migrated from IP tables, it's very convenient. And it's still missing a good number of optimizations that can be done, but that will come, hopefully will come soon in the near future. So let's pick up on the NF tables 1.108 updates. There is set packet city and mark based on IP DSCP field. In this case, to some degree, to some extent, the NF tables user space 2 is now capable of making two different data types compatible. We have started with a limited subset, and specifically one common use case that have been requested by users is the ability to set packet mark based on the IP DSCP field, and also perform some kind of bitwise operations on the DSCP field. This can be used to set the mark and city mark based on a packet header field. In this case, IPDSCP is smaller in size than the meta mark and city mark, which is 32 bits. But NFTables is from user space is generating all the bytecode to make sure that the assignment is correct, and it's also portable regardless the architecture, the CPU arch. So more updates are when in 1.08 for the optimize option. It's the ability to match NAD rules that use the masquerade statement, basically coalescing these rules when they have the same selectors. Also, for redirect statements, in this case, a map is used, an implicit map. So these two rules, basically classic rules, just to redirect the port 83 to some higher port ended by 82.2, and then destination TCP port 84 redirected to 8084. In this case, this is suggesting to use a map. So you redirect to based on TCP destination port, and then the mapping is provided. It's 88 to 83. Sorry, it was 83 before, and 84 and 8084. Error reporting also is a front from user space that is actively worked on to try to provide better hints to the user when user mistypes something that has been available for quite a bit of time already in Netfilter is this misspelled support. Basically, if you mistype the name of the table or chain that is being specified, in this case, when adding a chain, the table is incorrect, then it's going to suggest you to use the right table name. So just provide hints to the user when mistypes happen. and this misspelled support has been ported to work also on data type, existing data type, like the IP DSCP data type, which contains all possible values that are well known for this IP field. You can still use numeric values instead of symbolic values. Symbolic values you can check via NFT describe and then IP DSCP, and then it's going to show you the data type that is associated to this field. And here it's a mistype, and it's suggesting you that probably you refer to CS0 instead of CCS0. There's just some usability feature to try to make it easier to spot mistakes. There is room to improve many things, specifically from the parser side, but that can also be improved, and there is margin to improve it, and there are discussions that have been going on to make it better and combine it with this misspelled feature. In the future, it can probably provide even more suggestions on things that don't make sense. Then in terms of set updates, it is now possible to use constant values in concatenations. So I guess that this use case came also from someone using port knocking, but I cannot be sure how this is used. So basically, in this case, the user specifies an update on the set S1, which is a dynamic set, and the IP source address that is used as first component in the tuple that represents this element is variable, depends on the packet field, but the remaining components in this tuple are constant, which is an IP address and a TCP destination port. It's so now you can use also constants here. This is possible. A common request that have been coming is to speed up listing when there is large set, the previous versions of Nftables, where the catch logic was dumping the set content for the whole row in inet table, in this case, in this example there. So and if there was a bogons, for example, a bogon set containing lots of IPv6 addresses, then the time to show the listing was significant, because the set content was dumped was fetched from the kernel for no reason, not to be displayed, right? Which is silly. And then now with the latest version, this is basically skipped, which speed up things. So improvements in listing. It is now possible also to combine DNAT with expressions such as numgen. This is basically using the number generator expression, which is incrementing, starting from 0 and incrementing by 1 for every matching, up to 7 inclusive, so from 0 to 7. And then the offset is actually encoding an IPv4 address. This was not working before because the data types were not compatible. Numgen was generating a host byte order value, and DNAT is expecting a network byte order. And now user space realizes that where this is going to be used is the DNAT statement, and the DNAT statement needs to be in network byte order, so it's introducing the network byte order conversion to make things work. So you see the right IPv4 address that you want to use when implementing. There is no support for this in IPv6, but there have been some discussions on how to make it. More updates on Nftables 1.09 is the possibility to use constants again inside in set statements, such as add to a dynamic marked set. So more enhancements to use constant there. In this case, just a constant key. I guess this is also used for port knocking, I suspect. And then fixes, lots of fixes went into the map leak when wildcard interface is used inside a set, either implicit or explicit. There was a regression that broke interval maps when used with stateful objects such as counter. This also provides a scalable way. This was supported. This support was added a long time ago, but this was basically allowing you to scale up your rule set when you have lots of these stateful counters with a explicit name, and attach them to some selector for matching. Just for example for metering, and this got broken. Now this is fixed. Also this got broken too, and there was another regression that has been fixed. This has been reported recently. It's basically when combining metamark with bitwise operations and then verdict maps to jump to chains based on the value. Make sure that this keeps working. Yes, this example is matching on the metamark. It's shifting right 8 bits and then taking just again 4 bits of them, and then based on that just make a decision on where to jump. What is the next chain to be inspected for this packet. In this case, the chains are very silly. In the example, they are just counting packets, but well, you could just specify a more the filtering that you find convenient for your policy. So now a very quick update on the on the Netfilter workshop that happened just a few months ago. It was a 2 days meeting in Dresden in Germany. We spent almost one day discussing existing bugs and taking the time um, to find the best fix, the best possible fix, and some of them were already fixed, some others are still pending. So basically we iterate over Bootzilla looking for what is there. There is a good number of feature requests in Bootzilla too. So, and, um, and then another day was dedicated to an assorted number of topics. We spent a bit of time discussing about BR Netfilter. BR Netfilter is a module that is available under the Netfilter Bridge 3. It's rather old. It's been there for a long time. It's very popular, but it's broken in many different ways. It's a module that was made at the time that EBTables was not able to have the same capabilities than IPTables. So basically, IPTables is quite restricted if you have a look compared to IPTables. IPTables have more than 100 matches and targets, and IPTables have way less than that. And also, it doesn't have any kind of stateful NAT, and it also doesn't allow you to do stateful matching based on contract, right? So a long time ago, someone came up with the idea of making a module to basically, it's a shim layer to take bridge frames at bridge level, and then just modify those packets to make them look like an IP packet, and then inject them to the IP4 hooks. So then the packets run IP tables. There is a match that is used for this, which is the three-step match, which is also very common to be used to match on the ports, on the bridge ports. And then basically it was allowing for users to express their bridge policy using IP tables, just basically to circumvent these two limitations I said. It's lack of NAT and lack of stateful filtering. But as I said, it comes with many different problems. We are likely going to deliver a list of this. Florian Westphal, he proposed to start writing it, so at least users are aware of what they're doing with this. And it doesn't make sense in 2023 to start a policy with this module because of all these problems. You are going to hit these problems in one way or another as you evolve with your policy, and some of those problems really have no problems because they are related to design and architecture. So it's a bit like broken by design. So the way to fix this is to provide a native way to overcome the existing shortcomings of EBTables. And NFTables Bridge is a lot more expressive. It comes with a stateful filtering. It also provides let's say, same way to do a stateful NAT when combined with Bridge. I'll show you in the next slide how to do this. So there have been improvements in the test infrastructure, basically targeting the kernel API. There have been quite a lot of scrutiny of the kernel API, especially active in summer. And it has resulted in a good number of fixes that have been backport to stable kernels. And I'm basically working on improving test coverage by adding a test infrastructure that is going to be specific to the kernel API. And then there have been discussed flow table updates to speed up forwarding, which are still under discussion, and that we hope to post some patches soon. There has been also discussions to use XDP for flow table acceleration. So basically, we took a bit of time on that. To expand and improve the test infrastructure at kernel API level, this is work in progress, and address recent bugs reported due to lack of sanitization or error unwinding path. Some of them were catched by people running syslog. Basically, the existing test infrastructure we have cover user space interactions through the NFT interface, and there was a lack for some lower level API that is closer in touch with the kernel API. And this new test infrastructure is very minimalistic, utilizes and resides in libnftnl, although there are proposals to store it in nftables user space, so maybe it might end up there. But it will reside either in libnftnl or nftables, so you'll find it there. And provide a common framework to the kernel API box, so people can provide a test unit which is very simple to express without a very large file with lots of boilerplate code using libnftnl, which can be a bit chatty. And this is how the test API look like. It's basically, this is fast. It creates a test batch, and then you set up the batch. And then you add a table, and then you can add chains. The chain, all the fields are strings, because null means that field is not set on. So it should be possible to add test to send to the kernel netlink messages where this attribute is missing. And there is one for each object there is a function to create and to relate these objects. This is simple. This test is rather simple. There are more complex tests, but the idea is that the test does not cover does not take more than 20, 25, 30 lines of code if at max. So it's quite easy to understand by reading the test code. And finally, as I said, the Netfilter issues that we discussed, there are native replacement. I've been telling that we don't have much more time. So the native replacement basically consists on allowing you to do stateful filtering using nftables bridge family and the nf contract bridge module. You don't have to mod probe this module. It kicks in when you use the set city state expression from nftable bridge rule. So yes, you can use a city state from bridge, which is something that iptables does not allow. And that's why people are using iptables plus the BR Netfilter module, right? So this requires that if you are migrating from BR Netfilter and iptables, it requires a bit more effort because it's not so straightforward. There is no translation for rule sets. The fees depth match is not available in nftables for a good reason. It's because we would like not to expose BR Netfilter. And we prefer that users do the effort to migrate to this more sane approach, which is actually not going to be have the shortcomings of the Netfilter. And then for NATs, you can set the Ethernet destination address to specify the BR0, let's say the bridge interface MAC, and to pass out packets to the IP stack, and then use the NAT family in use the inet family to specify your NAT rules. So basically just add a rule to specify that packets needs to go up to the IP stack, and those packets that go to IP stack, there you apply the NAT policy that you like. So basically packets leave the bridge and get to the IP stack, and then there you apply the NAT, which is a problem for BR Netfilter as it is done these days. Because that is applied from layer 2, and there is a number of corner cases which are not properly handled, such as floating and multicasting, and it's very hard to fix without actually providing a new architecture design. So we are expecting that the users start picking up on this, and this nftables bridge and nf contract bridge grabs some traction compared to using the Netfilter. And that's all what I have. If you have any questions, I see there is a number of questions. One thing I have seen in the past was where chains could be named the same. Is there a reason for not enforcing name uniqueness? Just wondering. Also, this may be on the version I was using, which I can't recall at that time. Chain names can be should be unique in the same table. So it should not be possible to define two chains with the same name in the same table. But if you have different tables, it should be possible to use the same name. I'm not sure if that is precisely the questions. Otherwise, just please. New question added. I would like to say that if that is going on, it should be a bug. I would be expecting that is a bug, and it would be good to have some sort of reproduction. But I don't think it's possible to create two chains with the same name, because the chain, if the table and chain allows to identify where to place a rule. So if there are two chains with the same name, then it should not be possible to know to what chain the rule is going to be added. So no idea. Maybe it's a super old book, but I don't remember to have seen this in the past. As I said, any kind of reproducer, just feel free to send me an email with the details. I will have a look. So if you have no more questions, yes, you can. Is it possible to match on panels, on panel fields such as VNI? It is possible to match on VNI, yes. And as for sub TLVs in Geneva, it's not possible. That would need to be extended to be able to do so. There is an expression in Neftables, which is the NFT extension header, and it should be possible to teach it how to deal with Geneva extension headers. So the extension header has been sub TLVs in Geneva has been left for future work. Nothing else on my side. Thank you very much for attending my presentation. And as I said, if you have any comment, questions, I'll be glad to reply to you by email. Unfortunately, I could not attend this time. It's been a bit time constraint, and hopefully I can attend the next conference.
Okay, thanks, Pablo.
Thank you, everyone.